In the previous video, we introduced how to multiply rational expressions. The process is very similar to multiplying fractions. So first, we use the rule to multiply straight across. When we do that, we may leave them as a multiplication form because the second step, we need to factor the numerator and denominators. So it's easier to just factor the small numbers. 9 as 3 times 3, 10 as 2 times 5, instead of multiplying 9 and 10 to get 90 and try to factor 90. And so we can also do the same thing. With the variables, we could leave them as they are and try to find the common ones to cancel later, but it's easier. It makes it easier for us to see which ones, because it's not so difficult to multiply variables. So when we have variables, we could just go ahead and multiply them to get a squared and b fourth. And also, in this way, we won't see a lot of factors a everywhere and a lot of factors b everywhere. So we're just going to have one single factor of a and one single factor of b. With the numbers, we could leave them, and because again, for the same reason, it's easier to just factor smaller numbers. As you can see, I factored 4 as 2 times 2, 9 as 3 times 3, 10 as 2 times 5, and so on. This process can be omitted if you can just reduce directly, like 4 and 12, 6 and 9 directly, as we talked about before. So the other way is you can factor all the way out and to cross out common factors. And there's another 2 here. And for variables, we see that a squared and a fifth. A fifth has 2 copies of a, so we can cross out 2 copies of a from a fifth to leave us a third. And the same with the b squared and b fourth, we could do the same thing. Cross this out and to get a b squared there. Okay. Well, technically I was supposed to do it to do this step right here. So we cross out all the numbers and variables. And after that, we can just multiply straight across. So the top only has b squared and the bottom has 3 times a cubed. And that's all we have. And in this problem, we didn't have to do any factoring because every number, every variable is already a factor. 4 is a factor of the top, 9 is a factor of the top, 10 is a factor of the top. Or you can say, after you break it down, you can say 2 is a factor of the top, 3 is a factor of the top, and a squared is a factor of the top, and also b squared. And the reason is we only have multiplications in this problem. We don't have any plus or minus. So as you can see, I specifically use the dot to represent the multiplication times, all the way through. And the same for the bottom. We have only multiplication. So that makes every number here, every variable here, a factor. And that's when we can just cancel the factors. But in the next example, we may have rational expressions. For example, like this, the top has 3 terms. The bottom also has 3 terms, which makes t squared not a factor. And so it's different from the first example we did, because b fourth or a squared is just a factor because it's all multiplication. But in this case, t squared is not a factor because of the minus here, which means, again, t fourth is not a factor. We cannot cancel t squared and t fourth anymore. Okay, so in order to cancel the common factor, we have to factor everything out. So the first step still multiply straight across. And this step may be omitted if you just leave them as it is, as they are, and you can go ahead and factor each of them. But I'm going to go ahead and put the top times top. This is the top, first top times second top. And the bottom times bottom. We have t fourth minus 16 times 5t squared minus 26t plus 5. Again, this step may be skipped. The next step is, the important step is to factor the numerator and denominators. So we are going to factor each one. T squared minus 3t minus 10, it's a trinomial, so we can factor it. So I'm going to skip the factoring process, which is the box method that we learned before. So I can factor it as t plus 2 times t minus 5. And the second factor, I can factor out a GCF, 3t squared, and divide each of them by 3t squared. And that gives us t squared plus 4. So we take this, divide by 3t squared, and take that, divide by 3t squared. And the bottom, t fourth minus 16. So let me put the process here because it takes 2 steps. So first of all, t fourth is t squared squared, and 16 is 4 squared. So that's difference of 2 squares. I can get t squared plus 4 times t squared minus 4. And t squared minus 4, notice that it's also another difference of 2 squares because 4 can be written as 2 squared. So that part can be factored as t plus 2 times t minus 2. But t squared plus 4 cannot be factored any further because we don't have the sum of 2 squares. We only have the difference of 2 squares. So I will leave t squared plus 4 as it is and factor t squared minus 2 squared as t plus 2 times t minus 2. All right, now next part is another trinomial. So we can also do the box method, and we should get t minus 5 times 5t minus 1. All right, now we're done with all the factoring. One thing we need to notice that after we multiply straight across, we do get factors because it's a multiplication between these two. So t squared minus 3t minus 10 can be considered as a factor. This is a factor of the top, and this is a factor of the bottom, and that's a factor of the bottom. But if we don't factor them further, we don't see any common factors because you can see the top and the bottom, they don't have anything in common yet. And so that's why we decided that maybe we should factor them further to see if they have anything in common. And after we factored each factor further, we do see more factors. For example, t plus 2. And notice it's multiplication here, and t plus 2, it's a common factor. So if we did not break this down, we wouldn't be able to see this has a common factor of the bottom. But after we factor them down, we can see they have something else in common. And similarly, t squared plus 4 and t squared plus 4, it's a common factor. We can cancel them out. And there's also t minus 5 and cancels t minus 5. So now we cross that out. All the crossing part can be put down in the next step. So some of the steps I wrote down that technically we have 4 steps, but some of the steps can be omitted. For example, the first step, you could just go ahead and factor this, and factor that to go to there. And then the crossing part, you can also work on the problem. So without copy them again and cross them out. So now we will get copy down the final answer. The bottom we have t minus 2 times 5t minus 1. And the top, everything is crossed out except 3t squared. And we copy that. And the bottom we can leave them as it is without multiplying out. And that's allowed. But usually the top, if there's anything, we should multiply them out. Okay, so you can see the process. If you have a lot of terms, polynomials, and the process is still the same, but it just takes a little bit of time to factor each factor further, so we can find other common factors. Comparing to the first example, that everything is already factored because we don't have addition or subtraction. So now we're going to look at more examples. In this case, it's a division, and also we can follow the rule of dividing fractions. We know dividing fractions, we do keep, change, flip. or you can say multiplying the reciprocal. So for rational expressions, we use the same rule. So we keep the first one and change division to multiplication and flip the second fraction. So that was the rule when we divide fractions. Also, it works for rational expressions. So we keep the first one, the first rational expression, and change division to multiplication, and flip the second rational expression. So flip the top to bottom, bottom to top. And next, we're going to simplify this, multiply them in the same way as we did in the previous example. So it's a multiplication now. Again, so in order to factor, in order to see what common factors they have, I'm going to go ahead, instead of writing down one more copy of each of them, I'm going to go ahead and factor each one here. So let's factor this trinomial. 2x plus 1 times 3x minus 5, the first trinomial. And the second top, this is minus 18 right here. So we can factor that as 4x minus 3 times x plus 6. So again, that's also the trinomial type. And the bottom we have, that's also another trinomial. So we can factor it as x minus 4 times x plus 6. And the last trinomial we can factor it as 4x minus 3 times 3x plus 5. Correction here, that should be a plus and that should be a minus, because in order to get positive 6, we have to have 2 times positive 5, that's a positive 10 minus 3. Okay, so now we've done the major step, which is factoring. So everything is factored now, which cannot be, neither of these factors can be factored further. So now we just need to find the common factors so we can cross them out. So for example, 4x minus 3 and 4x minus 3, x minus 6, x plus 6, and 3x plus 5, 3x plus 5. And let's copy down what's left. We have the bottom, x minus 4, the top, 2x minus 1. And that's the final answer. And again, we cannot cancel this x and that x because this x is not a factor. It's just a term. It's a factor of 2x, and 2x is a term of the top. So again, x is not a factor of the top. And this x is not a factor of the bottom either. So we just leave it as it is. So this is the final answer. We can look at one more example. Again, this is a multiplication, so we are going to multiply straight across and factor each one. Notice the top has 4 terms, possibly it's grouping. So we can divide it into 2 groups. So the first one, first group, they have x in common. So we can take out x to get a y plus 2c. And the second one has a 2 in common, so we can factor 2 out. And again, that we get y plus 2c. And notice that they have a common factor y plus 2c. So we can factor that out, pull that out, and we are left with the x plus 2. Similarly, we can factor the bottom the same way to get another. So this one you will have pull out x. That gives a y minus 3c. And then pull out a 3, you get y minus 3c, and they have a common factor y minus 3c, so we pull that out, and that gives us x plus 3. And that part, notice that they have a x in 4x, greatest common factor 4x, so we pull that out, and that gives us x squared minus 9. And x squared minus 9 is different to 2 squares, so we factor that further to get x plus 3 times x minus 3. The bottom also has a greatest common factor 2x. We take that out and gives us x squared minus 2x and minus 8. And that's a trinomial which can be factored further. So the bottom can be factored as x plus 2 times x minus 4. So now we cross out the common factors. X plus 2, x plus 2, x plus 3, x plus 3, xx, and cross 2 out from here, we got a 2. and then copy down all the left terms.